All right. Yeah, let me come back to the call. Yes. Hi everyone. Thank you for joining the call today. And I'm not sure if you've been active on the platform. You would see that I released like the week 4 videos earlier today. I recorded them last night and I released them today. So at any point in time, you can go through the videos. Um, so some comments on what we did last week, or what has happened last week. Emenike did a PR, which was, it was really nice because when he did the first PR, I made a comment and requested changes, and he was able to like fix the changes and like commit it, and then I merged the PR. So currently, Ibrahim, I think you're the only one left. Yeah, you and I were supposed to have a talk, or I was supposed to help you with your VS Code. I
I
think
did a
that's.
PR. I did a PR and
Oh,
commented on
wait, chill. What's your?
RPG.
Oh, it's you. Sorry, Emenike. Emenike, you are the only one left. Yeah, sorry. I think that was Ibrahim. Ibrahim, I'm happy that you were able to sort out the VS Code issues. Yeah.
Yeah.
Anyway, without further ado, let me just get a feel out from the room. So I'm gonna go around each one of you. I'll start from Ibrahim because you last spoke. Ibrahim, so we're in week 4, which is like so imagine this is a 3-part course. We're entering into this. Actually, this is the end of the first part of the course. So have you reviewed all the previous videos, or tell me where you are so I can get a feel?
I'm still on the second video where you have the core logic. So
Okay,
I'm still on that core logic at the
okay,
moment.
all right. Second video, all right, got it. Okay, I'll move to the next person. Toby, welcome. Have you what week are you on, Toby?
Yeah, good evening. Uh, to be honest, I've not really been participating for the last 2 weeks. I've been a little busy with my
Okay.
final year project for that.
Okay. All right. That's fine. Take your time. I mean, it's on demand, so you can always watch it when you're free. Eminike, how's it going with the content? What week are you on?
I think I deserve to be punished.
So, okay, all right. So we can see, okay, so you guys are still within the first 2 weeks, less than or equal to the first 2 weeks. We leave it at that. All right. So we have week 3 content, we have week 4 content. I would say week 4 is where, like I said, the format that we're taking is we are doing little side missions, and the end goal of these side missions is that we're going to couple all the side missions into one mega mission. And so I'm touching on topics that are going to help us in our final mission. And this week, the topic that I touched on was something called an ERC20 token. So I'm going to share my screen for that. 1 second. Share desktop 3. Cool. Boom. Okay, you should see my screen now. So an ERC20 token, I mean, whenever you can get around to watching the videos, an ERC20 token, this is generally what an ERC20 token is. It's like the real world equivalent of an ERC20 token is like your pounds, dollar, Swiss francs, naira, name it, your currency. Um, and the idea behind this is if you're able to have a representation of a currency on chain, you can do currency-like things. I'm going to come to this place and show you something here. Go back. Actually, let's just come here. Top tokens. So these are the top tokens currently on the Ethereum blockchain. Ethereum blockchain is one of many blockchains. Um, the token with the highest number of orders is a token called USDT. Some of you might have heard about it. Some people use it for money transfer. It's that popular now. But the general idea behind USDT is that it is marked one to a dollar. I don't think the price moves as much. I think it does. I mean, but the movements are not very like variable. It's always around a dollar. So for that reason, they call it a stable coin because it is literally stable. And the company behind this is called Theta. What they generally do is when you buy 1 unit of this, they take your $1 and then invest it into some long-term and short-term assets. I think mostly short-term assets. By assets, I mean like bonds, government, US government bonds. So technically, they're trying to tell you that what you're buying is like you are, what's a currency? A currency is a promise to pay something. So the equivalent of them buying the bond is you saying that, okay, the government is saying I will pay you back for the money that you've given me in the future. But you don't obviously get the interest. They get to keep the interest. You just get to use the token. So they are bearing the risk, so they get to keep the reward. This USDC, the third one is very much like it. They are called stable coins. You see it's 0.9998. I use both of these, this more than this. This is also run by a different company called Circle. They're pretty popular now. I think I saw on LinkedIn recently that they were doing some stuff with I think Google, but who knows? Anyway, yeah, this is another token called BNB. I'm not sure if you guys have ever heard of Binance, but this is the Binance equivalent of like the Ethereum token. So you use this to pay for transaction fees when you're on the Binance chain. As you can see, 1 unit of it costs like $879, which is kind of like a lot. So people buy these tokens, and when they buy them, they expect the value to go up. So this is a non-stable token. As you can see, the price moves up and down. These are all ERC20 tokens, by the way. And so what you're going to be doing today is you are going to be building your own ERC20 token. Of course, it's not going to have any value because there is a process to giving it value. But the bottom line is when it comes to dealing with the project that we want to build, a very important thing is being able to deposit your ERC20 token into a contract and being able to withdraw your ERC20 from that contract. So think of an ERC20 in this context as maybe like a US dollar, and think of your contract as maybe like a bank. So you need to be able to pay the bank and get money from the bank when you want to. So in this course, I show you how to deploy your own ERC20 token and how to use it in quotes. So everything is in the video. I would not be like rehashing everything, but I'll just go through just so you can use this video as a companion video if you get stuck in the main video. So the ERC20 token is actually a standard. So I would say think of USB-C. Whenever you want to connect to a device, you always check, oh, does it have a USB-C port? So that's what a standard is, and that's what the ERC20 is. So the ERC20 is a type of contract where everybody came together and agreed that this contract is going to represent money. So if I'm going to write any contract that's going to be some kind of money type token, you have to implement this standard. The standard is written by a company called OpenZeppelin. They're one of the biggest companies in the blockchain industry in the sense that they're big in terms of their contribution because they've done a lot of contracts that they've standardized. A standard contract it's a good contract because you don't have to worry about bugs being in the contract. It has already gone through audits. It's basically certified fresh, or it's how do I put it? It's like the industry certifies that, oh yeah, this is a quality product. That sort of stuff. Back in the day, when you were doing blockchain interviews, one of the first things they will ask you to do is deploy one of these contracts and then use it for something. Actually, they might not even ask you to use it, they'll just ask you to deploy it. Now, I can say that that's the least possible thing they will ask you. Today, they will probably ask you deploy one of these contracts, create a another contract that uses the contract to do X, Y, Z. Technically, that's what we're doing today, So we're going to deploy an ERC20 token and we're going to use the ERC20 token in another context. Obviously here, this is what an ERC20 token looks like. It's not big. It's less than 8 lines of code, and I can show you. Oh, okay, 11 lines of code. Well, I mean, if I take this 10 lines of code, right? But if you notice, if you're observant, you might notice something different. Typically, in our old contracts, we always had contract, phone book, and then, the body of the contract. But here we have contract is something. Now, I'm not sure if any of you are from a computer science background, but there is something called the inheritance. So the idea behind the inheritance is that it keeps you from repeating yourself. So somebody defines something that is like abstract. They say uh an animal is or they'll say a dog is a four-legged animal that barks. And maybe it's carnivorous, but can also eat like human food. And then somebody who wants to create an Alsatian dog says an Alsatian dog is a dog but has these extra features. Somebody wants to create like a poodle, would say a poodle is a dog but has these extra features. It's tall, it's hairy, it's that, you know, and basically, so that's what inheritance is. So in this case, we're creating a token called token, but the token is ERC20. So that means the ERC20 bit has some features that we are inheriting. If I click on this, come and click on it, it takes me in, and then you can actually see all the stuff that is in the ERC20. So, I mean, you're going to see all this in the video. The idea is we are inheriting this stuff instead of having to write it from the scratch. It doesn't make sense for us to write it from the scratch, to be honest, because it already exists. So a lot of the stuff that we're going to be using in Web3, we try as much as possible to use stuff that already exists because you don't want to keep reinventing the wheel, if you don't need to. So there's some conditions though. You guys are familiar with the constructor, so I'm not gonna describe it anymore. The conditions are when you're making this ERC20 token, you kind of have to give it a name and a symbol, and then you can specify some additional thing. But these two things are a must, and I can show you. If you come into ERC20 token and you come to constructor, you can see it forces you to provide a name and a symbol. Everything else is optional. So you pass in the name, you pass in the symbol, and then you have your ERC20 token. Yeah, I mean, since we're here, and since it's not going to cost me any time, previously I deployed an ERC20 token. So what I did was, let me see, do I have any deployment instructions? No, I don't. Okay, so I'm just going to deploy a fresh one. Where is it? So let's give it an initial supply of, let's come here. This is 15, right? Let's say 1.5. Okay, 150. Yeah, 150 tokens is good. So we come here, give the initial supply of 150 tokens. Yeah, I'm just going to state again. The reason why we use these big numbers is because of precision. And if I come to token ERC20, I'm going to show you some things. If you come to contract and come to read, and you come to decimals, you can see this particular token has 6 decimals for precision, just 6 decimals. But some other tokens have 18 decimals, and I'm going to show you one of them. This one has 18 decimals. So the reason why the stable tokens tend to have 6 decimals and the non-stable tokens have 18 decimals is because of this. I'm just going to show you. I mean, it's not important. Nobody's going to ask you this question, but this is just for you to know. The price of this token is often always 1.00. So if you add 6 zeros behind this, the price is not going to massively be different. Same with this one. It's not going to be massively different from 1. It's always going to be approaching 1 from either the top or from the bottom. But this one can have a lot of values. You can, because the value is always changing. And there are some protocols, like the one that we'll be making, that the change in the value actually becomes something, an input for our program. I'm gonna go off a tangent here a little bit, and I'm gonna show you this. I'm sure everybody on the call knows who Donald Trump is, so it needs no introduction. He has a token named after him. The token is called where is it? Where is it? Where is it? Where is it? Wow, has it gone down that much? Okay, let's find it using the search. Trump. The token is called Trump. I think this token was deployed on Solana, so technically it's not a good example. But Solana is a different blockchain. But the token, this is a token, and let's see the all-time. The price of the token has moved, like it pretty much was from a high of I think it used to be $44. It's now like $8. So if you bought here, it probably goes down. I mean, this is all a lot of the industry is. But the reason why we have 18 decimals is because somebody can buy a token here and then maybe the good example is someone can borrow this token here, and when they borrow it, they sell it and then they buy it back here. And then the difference between the price here and the price there is in quotes their profit because they borrowed it to sell to buy back in the future. So all those 18 decimals would really count over like a lot. And there's another token that I will show you, Ethereum, which is the base token that we use for our blockchain. You can see the value is going up. For the loan app that we're going to make, we would allow people do things like deposit Ethereum, and when they deposit Ethereum, they will take out a loan at the value, like a loan based on the value of Ethereum at the time when they deposit it. So maybe they deposit 1 Ethereum and the Ethereum is like 4,300. They can take out a loan up to like half of this value, which would be like 2,170 something. So they will be able to take up a loan for that value, and we would be paying attention to the loan such that if the value of the price of Ethereum should suddenly drop to maybe, let's say, so the loan they took it at 4,000 and they got 2,100, and then all of a sudden something happens and the price of Ethereum just drops back to 2,100. Immediately that means that the amount that they've borrowed is almost now equal to the new value. So we need to be able to tell them, oh, look, it seems like your loan has now reached like a risky your loan is now deemed risky. So we are going to sell your Ethereum so that we can pay off your loan so that we don't lose the money, that sort of thing. So that's what we're going to be building, by the way. We're going to be building like uh, that feature, and it's a very big feature. I think I showed you guys during one of the first calls that one of the biggest apps on chain, Aave, I can show you again. One of the biggest apps on chain, Aave, has $57.5 billion based on this model. So basically, the thing you're going to build by the end of this course, these guys have it, and the same thing that literally the same thing, they have 57 billion in it. And out of the 57 billion, they've borrowed 23.97 billion out. And they still have like 33.57. Like today, if you wanted a loan, you can get a loan from them. You don't need to pass any special checks or anything. You just deposit your collateral and then you get access to like USDT or USDC, which you can go and spend, on whatever you want to spend. So yeah, I mean, it is a really interesting market. So the decimals matter when you are calculating interest on loan. So imagine like you have only like two decimal places, but the interest, because it's a blockchain, the interest is calculated per second. When you multiply that two decimal places by maybe 80,000 seconds, which is technically the amount of seconds in one day, it's actually 86,400, but 80,000. You would see that the difference in value between two decimal places and 18 decimal places, it adds up. It adds up significantly. I'm not sure how many of you have a maths background. I'm not going to go into the maths of it, but if you're ever going to like go into it, just maybe research rate of return on an asset, it's e raised to power RT, but I mean it's out of the scope of this course, so I'm not gonna bore you with it. We're gonna do something interesting with that anyway, but when the time comes. So we've digressed and we'll come back to this. Let's deploy our token. This is the token. So boom. Now that we've deployed the token, you can see it has some features in, but you do not see the features here. Why? Because of inheritance. You are inheriting these features from ERC20 because ERC20 has all these features. Decimals, 18 decimals, kind of like what I showed you for the deployed contract. The name, gold, symbol, this. Of course, you can change the name. You can name it Zoe, and it would deploy it, and it will be Zoe. It can be anything you want it to be. Nobody really cares. This token technically doesn't have any value right now. In order to make it valuable is something you have to do. But if you want to learn about that, maybe ask me on Tattle and I'll send you some links. Yeah. So this is that. This is your token. Now, this a lot of people do deploy this stuff and then I mean, many people have scammed people off these tokens. Like they will deploy a token and then they'll fix a price for it somehow, and like people do all sorts of things. But like it's kind of like the fundamental unit of decentralized finance, the token. It's the most important thing. Within the token, you can approve a transaction, you can transfer your tokens, you can transfer from like your wallet to a contract. You can set an allowance. Technically, when you do approve, it does this. You can check your balance. You can do so many things. We go into all that within the course. Yeah, let's move on to the next thing. So yeah, that's the token. The next thing is the management contract, which is kind of like your bank contract. So let's go to it. So what does this management contract do? Within management contract, obviously, you might look at it and say, oh yeah, this is kind of daunting. What's the meaning of all this? But when you watch the video, you see that we actually build it step by step. You might see some things that are familiar. This should be familiar to you. This should be kind of familiar. This too would be unfamiliar to you. When you watch the video, you're gonna understand. But what I can just tell you what I did. So management contract and token, they sit in the same folder. All I did was I just imported token into management contract so that I can access like elements from like token. So if I come here and I say my token and I do dots, you can see all the elements from it begin to show up. So I can externally call it. So this is one of the cool things about smart contracts, right? Smart contracts can talk to each other. Um, a smart contract can talk to five, six, seven smart contracts just to do one thing. So smart contracts, I mean, that's the beauty about smart contracts, the fact that you can daisy chain them together to do something. So, but in this case, this management contract is only talking to my token. And I ensured it's only talking to my token because I got the deployed address for my token, and then I got the object for the token, and then I kind of like created like a pie where I put the address within the token to access a particular object. So there's two components to every contract. Every contract has like an object, something called an ABI. Um, that question might come up within your interview. It's possible. So you can note that down. The ABI looks like this. This is the ABI. Every contract has an ABI and an address. Let me see if I can show that to you here. Where is it? Where is it? Where is it? This contract. So this is the contract address for, where is it? The contract address for this token is here. This is the address. But the ABI is here. This is the ABI. So the ABI is just like an instruction set, and the address is like the where the instruction set is pointing to. So you can have one contract can have different addresses, but with the same ABI. So like it's something that can happen. I'm not sure if we're gonna cover those kind of scenarios within the course, but it's something that can happen. In that case, the contracts are like clones of each other. They're identical. They just have different instances, you know, and different instances means that they have different storage. So they store data differently, and but they all have the same patterns, like the same functions you can run on them, that sort of thing. This is kind of like how you have different cars, but all of them have like maybe they're each unique identity. So maybe you have the same car from, like, you have a Toyota, two Toyotas from the same manufacturer, same model, same everything, but you would find out that their vehicle identification number is different. That's how it is. So same but different addresses. It's a possibility, you know. So yeah, so that's the ABI. The management contract. So basically, what we did here was we took the ABI, we put the address in to access that specific instance, and then we begin to use the instance within our contract. So the first thing we do is we create a function called deposit. It's nothing special. You've seen this function before. The only difference was that in that instance, we were using the Ethereum token, which is like the gas token, or sorry, the transaction fee token. Gas and transaction fee are interchangeable on the blockchain. They mean the same thing. Um, in that case, we're doing like a payable, but in this case, we're not dealing with like an Ether token. We're dealing with like an ERC20 token. So it's no longer payable. You have to handle it differently. And this is how you handle it. The amount, you can increment, you can transfer, etc. Now, there's some things I'm just gonna go over with before we run out of time. I'm trying to wrap this up very quickly because the content for this week is also it's not a lot, but it's really important. Let me come to this management contract. So it's very important that when you want to deposit from your wallet, I put a note here. When you want to deposit from your wallet to a contract, the function you use is called transfer from. Let me show it to you. It's this function. This would be like your address. This would be your contract address, and this would be the amount you want to deposit. But you can't actually call this function without first approving. Let me see if I can demo an instance for you. So first of all, I am going to do this. Okay, let me approve. Where's the management contract address? We have two of them. Okay, you know what? I think I'm just going to do a fresh deployment for all of them. Okay. So first thing first, let's deploy a token. Token contract is, I think do I still have this? Yeah, deploy. So we created a token contract. This also supplies 150 tokens. The balance, what I did here was when I minted, where's token contract? When I deployed it, I gave all the supply to the deployer. So if I come here and I check my balance, I have all the balance. So it's me. I have everything. So now I want to deploy the management contract, which is going to be handling like the token. So let's deploy the management contract. Boom. Actually, no, not like that. First of all, I'm going to copy the address because this is a fresh instance of a token here. Then I deploy. Okay. Now my management contract can talk to the token just because I linked them together. So the first thing is I'm going to try to like deposit, right? And it's going to fail, by the way. Let me just give you an amount that I can deposit and see. Where is it? Boom, boom, boom. Yeah, copy. Where is it? Here. So I have 150 tokens, but I'm going to deposit 5 tokens, yeah? This is going to fail. It's going to tell you that insufficient allowance. Basically, it means that the contract doesn't have any right to take those tokens. So we need to go and create an allowance. So we're going to give permission to the contract that, okay, you can take these tokens. So the first thing is, and to prove to you that this allowance is issue is actually real, I'm going to come here and let's check the spender, which is the token, and then the owner is me, my wallet address, allowance 0. But now I'm going to call approve. This time the spender is this person, and I'm going to give it just 5 tokens to spend here. Now you can see it's successful. When I call this, boom, 5 tokens to spend. So when I come back here now and I call this, boom, transaction successful. You can see deposits, amount deposits, transfer, events deposited. And I can prove it to you by when you check this, you see it's lower than like it's 150 minus 5, so 145. 149. I must have done my calculation. Oh, I used a very small number. Yeah, that's it. 5. So I used a very big number. This is strange. Come 1 second. Let me confirm what this number is here. Cast from way. It's a really large number. Oh, this is okay, this is a really large number. I think I deployed with a really large number. I mean I think I realized my mistake. Yeah. Um I'm gonna clean up that again and just do a quick deployment so you know what to do and you know where I made the mistake. So if I come to token, I should do 150 or 15 basically. You know, total supply is 15, and then I can confirm that. Come here as a cast from way. You won't be able to do this, but don't worry about it. You can use the website 1500. Like you can do the same here. You can come to the website here and paste that amount 15, you know. I just prefer to do it in code. Yeah, so that's that. And we're able to deposit, as you know, but now our token has changed again, so I need to update our management contract with a new wallet, new token address. And we deploy a management contract. That's it. Let's get the address here and approve. But we want to spend only 5 tokens, right? So, boom. Let's come here. Okay. So, we come to our management contract. How much are we depositing? 5 tokens. Successful. Check the balance of my user now. 1495. Yeah, because it's 1500 minus 5. So technically, that's correct. So 1495, which is the right one. And as you can see, the five tokens have gone into the contract. They no longer sit within. So it no longer recognizes me as the holder of those 5 tokens. Instead, it recognizes the contract as the holder of the 5 tokens. In the same way that um the central bank doesn't recognize like your account with maybe Access Bank as like your account. It just sees it as Access account. So Access is the one that has the record that, oh, Toby owns this amount, that sort of thing. So that's why we created the mappings. The mappings is for internal accounting. So if we want to know who owns what of this 5,000 or 5 tokens, come to user balances. Um, boom. Here, you can see 5. Now I'm going to do something that I didn't do in the video. I'm going to so that's a contract, that's a wallet to contract transaction. I'm going to do a wallet to wallet transaction. So remember that like this, my user has 1,495 tokens. I want to send some tokens to the next wallet, which is this guy. So I've copied the address. I want to transfer to this guy, but I want to transfer 75 tokens. So let me say cast to way 75. Okay. Here. So I've done a transfer. Now, if I check my balance, it should have gone down even more. 1420. That's missing 80 tokens. 5 in the contract and 75 to the other guy. Now, let me prove it to you that it's with this guy. Come, let's check his balance. 75 tokens. So this guy can now deposit tokens into the contract. So let's do that. So he wants to give 15 out of his 75 to the contract. Yeah, he's the signer. So we send the transaction, and then we come here and we say, okay, let's deposit 15 tokens. Boom. When we then come to, so if we copy the contract address, the management contract address, and then we come to the balances, balance off on the token contract, and then you call balance off, you can see it's now 20,000, 15 from the other guy and 5 from the previous person. Obviously, it doesn't have the internal accounting like I mentioned. So the guy had 75 tokens. So technically minus 15, that's 60. So if I check his balance of the token is gonna say 60. But if I come here and I check, it's 15. So this is the internal accounting for the management contract. This is how we're going to know who owns what. So this is my user balances, you know. So the mapping has its own, my management contract has its own. So the deposit function, we've been able to do that. Obviously, in our loan application, the two elements of a loan is you borrow someone some amount, and at a later time, you can withdraw that amount with interest. The time has passed, but in this case, we're not giving interest. We're just paying out the same amount that you deposited in. So I'm going to try and withdraw from the contract. So let me go to an address that has not deposited. I'm going to try and withdraw 5 tokens. See what it's going to say. It's going to say, oh yeah, revert. And it doesn't tell you anything, the reason why it's reverting. This is actually very bad. It's bad practice. I'm currently having a problem at work with a contract that doesn't tell me anything, and I have to figure out what's going on. But yeah, I mean, sometimes it doesn't tell you anything. There are tools that you can use to debug stuff like this, but you can't kind of do them on your local blockchain. You can only do them like on like a shared blockchain. Yeah, so the withdrawal function worked. The more likely reason is because, it tried to withdraw this line. This is the line that generated the error because it's obviously not this one, it's this one. Yeah, so basically it doesn't allow a thief to come in and steal your tokens. So, but let's go to the second guy who deposited 15 tokens, and let's try and call withdraw for him. Instant success. So I have shown you a wallet to contract transaction. I've shown you a wallet to wallet transaction. I've also shown you a contract to wallet transaction, which is what I call in withdraw. To look at what's going on in withdrawal, this is what's going on. I'm calling transfer. When I was depositing, I used transfer from. When I was withdrawing, I used transfer. This distinction is very important, because when you're depositing, you first have to give your approval. And then when you give an approval, the contract is the one taken from your wallet to itself. That's what you're saying. From the wallet to itself, that amount. But when it's doing a transfer, it's just sending from itself to only you, the person who is calling. So that's our deposits and withdrawal functions, and they're very important for where we're going. I think one of the challenges I gave you in the video was see how you can instead of like doing like this rock paper scissors, instead of using the payable function, where is it? Instead of using Ethereum, try and create your own token and use your own token here instead. I think it'd be a very interesting assignment if you can pull that off, and just you can share it with me, I'm not going to I don't know, should I maybe put this on a GitHub? I don't think I should. I think maybe you should try that. Um, because I don't intend doing any more work on this. This phone book is going to change. It's going to change a lot. A lot of our work is going to be going into here. We're going to be, you know, updating this file. But rock paper scissors is just your own personal play project to get used to it. Another reason why I did this code in Remix is because I said at the start of the video that I don't want to be writing tests while I'm doing development because you are going to lose track of because I'll be switching between two programming languages. Um, I want you to focus on Solidity for now because there are ways to actually program in Solidity where you only use Solidity. It's called Foundry, but I'm not going to show you Foundry because when you want to, which we're going to do in the course, when you want to build a front end, you kind of need TypeScript because the front end can't talk to Solidity directly. It can only talk to TypeScript, which is why we're going to use TypeScript for our testing, and our SDK eventually. So yeah, this is basically what this week's video was on. It's nothing fancy, straight to the point. Um, I'm going to stop sharing my screen. I don't think I've ever spoken for almost 40 minutes uninterrupted before. Well, I mean, this is a first, it's gonna be a first time for everything. I think I have. I mean, I have spoken uninterrupted, but it was also on these calls. Um, you may have some questions, and I like to hear your questions before, I proceed. Who wants to go next? Okay, let me see. Who do we have in the chat? We have MNK, we have Ibrahim. I think Toby dropped off. Okay. Does anyone have any question for me? Raise your hand. Otherwise, I'll just continue.
Well, I don't really have a question, so to say, but I just need your input on this. Times in the middle of all this, I I don't know what I'm doing.
Okay.
But I'm doing something and I'm getting what I'm getting the feedback that you are getting on the screen. I don't know if I need to be worried now. I should just follow through. After a while, I'll get hold of things.
Okay. Is that regarding this week's content or last week's content or 2 weeks ago?
No, I'll be talking about last week content and this week content.
Oh, wow. Okay. I'm going to see if I can unblock you after this call. So, let's do this. Boom, 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 boom. Okay, so I'm going to stop the recording now because, obviously, um, we are going to